Good morning, everyone. Hello. So, can you hear me? Hello, everyone. I'm going to start a webinar on SolidWorks Simulation, and today's topic will be on the fatigue analysis, which we are going to use it for getting to know the durability of your products there. So I'm Manu. I'm working as an application engineer in Best Engineering, Aids and Consultancy Private Limited. And today's agenda is like this: we're going to have a introduction to fatigue analysis, and I'll just go through which are the things you should know before going for analysis using the SolidWorks simulation there, and we'll have one quick demo on the case study, like how we are going to use the SolidWorks simulation for performing a fatigue analysis, and in the end we'll going to go for like what are the key benefits you are going to get it when you are performing a fatigue analysis. So you can see out here mechanical failures have caused many injuries, deaths, and has impact on financial loss also over the years. And when you come across this mechanical failures, these occur due to the complex interactions of the loads and with the time and environment. And the loads may be a monotonic, steady, or a variable, or uniaxial, or multi-axial one. So it depends upon they are going to withstand the load for a year or some number of cycles. And you can see out here, these are some loadings, like it may be a thermal loading also, whenever you have a range of temperatures vary from cryogenic to the room temperature, then also it's considered as a one cycle. So it may also lead to fatigue failure. I'll just show you one just a video there where you can see out it's an IKEA chair testing machine what you do. So if you want to check that how much the chair can withstand the loading, like if you sit and again you are going to go away and again you are going to sit. So how many number of cycles it can withstand? So it's predicting like how much it's going to withstand is very difficult, and it takes a lot of time here. So you have to manually set up exactly the same thing like a person sitting there. So instead of spending a time and money on these type of experimental setups, we can perform a virtual testing of those in SolidWorks simulations. So when you come across mechanical failure modes, we have a set of failure modes. It may happen due to excessive deformations. It may be ductile brittle fractures. It may be due to the thermal shock. It may be due to wear, buckling, and corrosion. But out of that one, like fatigue analysis is the one which you have to consider in each design. So these are some examples what you are seeing in your screen there. Like you can see out there is a bulb which is when you go for number of cycles there, it may blow off, and there is an a bicycle crank failure is happening there, and in case of you can have vehicle steering linkages broken out, and pressurized you can say aeroplane fuselage. So that also got may broke may break whenever it come across a number of cycles, or we say it's a life. And fatigue failure is due to repetitive loading, and almost if you go for a survey of the failures occurring due to the fatigue, it is estimated that anywhere between around 50 to 90% all the mechanical failures are due to fatigue only, and it's very difficult to figure out accurately because fatigue is more often unpredictable. So let us see what is the fatigue here, like how you define a fatigue. A fatigue is defined as a failure under a repetitive, or you can say out as a varying load which never reaches a level sufficient to cause failure in a single application. What does it mean? Like your component may not fail in a single cycle, but repeated or continuous loading when you go for, so it may fail after a number of cycles. And usually the process of fatigue includes initial generation of the cracks. So the cracks will develop, and they will go on increasing their sizes there, and they will reach a point where the material is unable to withstand that load, and suddenly you find a breakage. And whenever you go for the fatigue analysis, we find a different set of methodologies available in present, you can say, market there. So we have the stress life approach, we have a strain life approach, and we also have a linear elastic fracture mechanics there. So here let us, in brief, I'll just describe what do you mean by this SN curve and SN approach, what is this strain life and linear elastic. So here in SolidWorks, we are referring to the stress life approach, and for this we obtain stress versus the number of cycles data should be there, how much will be the stresses induced in that material. So when you go on applying the loading there, so number of cycles, how it's going to happen, and this method is very easier, and it's easier method to implement, and has an ample supporting data there, and it has a, you can say out good representation for high cycle fatigue there. When you check out for more than 10,000 cycles and above it, so you find that almost the same results when you do for testing, or when you do it in simulation, SolidWorks simulation there, you will find the same values there. And this is a common method which is used for all engineering metals. So we have a strain life approach also available. In SolidWorks, we approach is SN only. What is the strain life? I'm just giving a brief there. So this is for considering the plastic strain effects, or and which are happening around the crack tip, and you want to measure the strain there during the testing. So these type of analysis, the fatigue analysis, if you want to perform, you require a strain life approach. And in case of the linear elastic fracture mechanics, it assumes that already some crack is there, and which includes, and it's going to consider the both the crack creation and propagation there. So whenever you come across cyclic loading, we have the fatigue usually occurs due to cyclic loading day, and this is due to the stress state. And we have like different type of loading conditions, like it may be a constant amplitude, or it may be a very variable amplitude. And as you see in these images, you can see out the load which is happening continuously. It is the same only what I showed in one video there, where you are applying the load on the shape. It was like a constant amplitude. Again, it's removing, it's adding the same type of loading there. And in case of variable amplitudes, it's like you can say out like a graph, whatever is seeing in front of your screen now. It is we cannot say it's a random one. It may, amplitudes may increase very much high, and they might come, they might become a very small amplitude also. So it's not predictable. We can just use it the data, and we can perform the analysis. And in case of constant amplitude, we can begin the various stresses here. And here we see a constant amplitude cyclic stress. For this, we can define a mean stress, the minimum and maximum stresses, which in turn define the stress range. You can just observe here. This is the amplitude of this loading, whatever is happening, and this range easily you can find out like what is the maximum, what is the minimum here. So based upon that, we can finally we can define the alternative stress also, which is the half of this range. This is an alternative, you can say the stress is there, which is half of the stress range there. And you can see a constant, and we can define all these data. So why I am telling about these amplitude, these mean stresses, because we have to define the data like SN curve, what I said, no? How the stresses is going to vary with respect to time. And whenever you come across fatigue analysis, you will also see the stress ratio there mentioned in fatigue literature. So what is that? It's a ratio of S mean by S max there. So and here it is equivalent to like loading ratio also. So we call it as LR. And if you take a special case where you can say mean stress is 0, and then the S mean equal to minus of S max, and the stress ratio will be -1. So this is for fully reversed one. This is called a condition, and as you can imagine, the stress is being fully reversed between the minimum and maximum. Another common stress ratio is 0 there. So these are the inputs which are going to give, which we are going to provide for performing the fatigue analysis, and this can see out, no, here R equal to 0. So whenever you have this type of stress ratio, we call it as a zero base, and this can only happen when the sigma S min is equal to 0 according to the equation, and defines the case when the stress is cyclically applied and removed from the structure. Okay, just you remember here. So most of the cases, whenever you come across the fatigue analysis, they might go for the zero bias way. They are cyclically applying the load and they are also removing the load. Now let us go for one simple example there on the pressure vessel, and you can see out its objective is to find out whether it's going to fail after 10,000 10 is to 6 cycles there. So what are the loading conditions? It's like internal pressure, and pressure of, you can say out it's 1000 psi, and it's a zero bias. When you come across R equal to 0, it means that the testing whatever is done there, it is zero bias and R equal to 0 here, and the pressure vessel is made up of aluminum alloy. The same thing whatever I explained here, you can just this is the thing what I discussed. Now how we are going to perform this type of analysis there? So what are the stages you come across in SolidWorks simulations? So first thing is you need to perform a linear static analysis which defines the alternative stress state, and after performing this you have to define the fatigue study. So what exactly you are doing here is like you are applying the same whatever the loading conditions are there and checking that whether it's going to fail for the single applications. So that may not happen. See, usually failure we predict by comparing with respect to yield strength. So if it is below that yield strength, we can say that okay, the stresses below the yield strength, we say that it's a safe one. So it may happen because of only a single type of loading, so it may not fail. So we want to check it like what will happen if I go for checking, go for analysis and fatigue analysis, where I want to check like I have some number of cycles. See, for as a customer, sometimes he will ask like, what is the durability of your component? So how much guarantee you are going to provide for this one? So I must be, as a manufacturer, I must be sure that how much it's going to withstand without a failure there. So for getting that value, we have to perform this fatigue analysis, and this is a like number of cycles we have to define, and as I said, SN curve is required here. So again, this is the stage one, the linear static analysis. As I explained, we have to define all the boundary conditions, whatever acting on that part, or it may be an assembly there. So these are the bolts will be there, and this is the internal pressure and where it is going to be restrained. And if you see out here, if you check out, if you also find that you may get that results, the stresses are below the yield. So in this example also, the stresses are below the yield. So we won't show the details of a linear static study here, since this is assumed that you know about this type of linear static analysis, and we want to just check out with the fatigue analysis. So just observe here, what is the second stage? So you have performed a linear static analysis. What you have to do for a fatigue study? You have to define a new study and defining a fatigue one. And here you need to add an event here. So what is that event? This event helps you to define the SN curve, and you can just observe here, and you have to define the setup here, like define the number of cycles, the stress or a loading ratio. As I discussed earlier, you have to define the experimental setup, how you have done and what are the results you obtain, and you have to refer the linear static study there. And again, as I said, the first thing is in fatigue analysis, you require a SN curve. It's a stress life approach we are following here. So when you go for the material way, so it's going to ask for the SN curve. So what is the life of a stress for 4005? So it all depends, like how much data you have here. So based upon that, we can select it. So there are different methods for plotting these graphs. One is log graph is there, log linear graph is there, linear graph will be there, and you can see out the results of, these are the stress results, log of the stress versus the log of number of cycles. So it will help the software to predict that whether it's going to fail or not at this stage. So it gives that value. Say after this number of cycles, what is the stress there? So it will consider that one, and it will compare the results of static zone. So it will be like it can predict that it's going to fail or not. Another thing, in fatigue analysis, we can have a damage plot and life plot also. So for that purpose, this will be very helpful in predicting. And you can just observe here, the stress ratio R is -1. It's as I said, fully reversed, those things we can just include it here, this ratio. And you can see out here, this is the number of cycles, and this will be the stress results. So after 7,000 cycles, so what will be the stress results going to occur in that material? So it all depends upon this SN curve. So if you are having a less number of data, you have to better go for the log interpolation method. So I'll come back to this one. Okay. So you can see out sometimes, or many times we see that we don't have that curve, SN curve there. So what you have to do is you have to just go for derive based from the elastic modulus there. So this will be considered from ASME standards there, where we're going to consider the austenitic steel curves. So from that, it will calculate automatically the SN curves. Again, it is like an approximations. If you want to have a more accurate result, you have to better go for the SN curves of the material which you are going to use it. See, many of the engineers or designers, they come across this one, say we don't have this data, SN data, how to predict, how to perform the fatigue analysis. So one of the thumb rule, you can just go through this one, you can note down this one. So the ultimate strength, you can take out here percentage. So we have to go for how to calculate the fatigue strength. So it will be the 90%, you can consider here 90% of ultimate strength, and for endurance limit, you can just go for here 352.6, times the ultimate strength. So this one, if you consider here, you can also perform the analysis, and you will get a plot here like this. If you see here, this is the ultimate strength, how it is varying there. So percentage, you can say fatigue strength, you can easily calculate here. It will be assumed that it's 90% of SU, and endurance limit is, endurance means is life, it is going to for, say designing for life. Assume that it's never going to reach that one, the level of the stress state, and it's not going to fail. So here you can consider it's a 0.5 times the SU there. So you will get a endurance, the graph which you can refer there, and for using it, you can use it for performing the fatigue analysis. You can see out here, this is a horizontal line showing that the material will last indefinitely, and below this stress level. If your stress level is lying here, no, it will never going to fail. Means the stress level is less. If you see out what are the outputs you are going to get it from the fatigue analysis, you will get a damage plot, and you are going to get a live plot also. So damage plot, it will showcase like how much percentage of damage has occurred in your part or an assembly there. It will showcase on that portion there. You will find a bar chart here. Based upon that, we can say that okay, this much amount of damage has been occurred here, and it is going to cause some issues there. It may lead to some catastrophic failure also. So depending upon the criticality, you can suggest like that whether it's going to get damaged or not. In the other side, you can just see out here, we have this live plot also. So that will be having in terms of number of, you can say cycles it can withstand without a failure there. So suppose you want to give a warranty to your customer there. So in that case, you can just go for this live plot also. Say suppose I am a manufacturer and I have to give my products to my customer there, and he is going to use it for say some 3 years. So I can just give the details also. Sorry, there was a loss in the connection there. I'll just repeat there. So as I said, we have these two plots here, like one is the damage plot and the other one is the live plot. So damage plot gives like how much amount of percentage of, so how much amount of damage has occurred in your model there. So based upon that criticality, we can showcase that okay, this much amount of damage has occurred here, and whether you are going to give the customer a replace or not. So this you have to decide it. And suppose you are going to give for the like warranty or guarantee you are going to give there. So in that case, you can just use this live plot. So where we have like suppose a 3 million cycles, without up to that one it's not going to fail. So in that one you can easily say that okay, it will last for 1 million. So we'll be in safer side. So even though he can continue using also. So this is on in brief on the fatigue analysis in SolidWorks simulation. There, we'll just have on benefits how we are going to go for performing the analysis. Thing. Okay, can you hear me now? So I guess okay. This is all about in brief on the fatigue analysis in SolidWorks simulation. And let us have a quick view on the benefits of performing a fatigue analysis. So you can see you can quickly and efficiently, you can say, adjust your designs to meet the required product life. Establish and this is helpful for you. Like in each design, you have to go for this fatigue analysis. You can go for any of a maintenance schedules also. Like, suppose you are a manufacturer and you are supplying some assembly mechanisms or any of this one. So you want to check out like it's going to have a regular maintenance so that it should not undergo a fatigue failure there, and it will also help you to minimize the failures and like reducing the warranty cost and maximize your product life. So we'll have a quick session on the questions there. So anyone has any questions?